In this chapter, we will be going over your b and a, which serve as your bounds or limits to give you definite integration. But in this case, we don't have a b and or a, simply because it's section 1 of chapter 4. So let's keep it simple. Let's use x squared, and the integration has the integration symbol and the dx, which is the variable by which we are integrating. Opposite derivatives, the rule for integration is x to the n plus 1 over n plus 1. So we follow this rule. We have x to the 2 plus 1 over 2 plus 1, which simplifies to be x cubed over 3. And whenever you don't have a definite integral, which means you don't have a b or a, you have to put the constant c to indicate that it could either be lower or higher on the y-axis. So that is the end of chapter 4, section 1. Now let's move on to chapter 4, section 2. Chapter 4, section 2 deals with the other form of integration, which is integration by approximation. And this is done using summation notation. Summation notation is symbolized by the symbol of sigma, where we have an n, a constant, or an I, or whatever. In this case, let's use a constant because there are 4 rules, and we have I is equal to 1. When there is a constant, that is as simple as it gets, and you just multiply the constant by the n. There will be cases in which you won't be given a constant, you will be given an I. And here's where things start to get a little bit complicated. The formula to find this out is n times the quantitative of n plus 1 over 2. Now there's going to be instances where there might give you an I squared. And to find this out, we get n times n plus 1 times 2n plus 1 over 6. And to go even further, which is the last formula we are going to talk to about in this section, is I cubed. And this is n squared times n plus 1 over 2. And this n plus 1 is squared. So, for time's sake, I am going to use an example that somewhat requires all of these rules to be used. And we're going to use E, the sigma, with an n of 5, I is equal to 1 of I squared plus 8I minus 2. This can be broken down into 3 parts. I squared plus sigma of 5, I is equal to 1, 8, and I minus sigma of 2, 5, I is equal to 1. And then from here we can just use the simple rules. This is a constant, thus we just multiply the constant by the n, which is 2 times 5, which is just 10. To find this, we need to do n, which is 5, times n plus 1, which is 6, times 2n plus 1, which is 2 times 5, which is 10, plus 1 is 11. So times 11 over 6. Plus, then we have n, which n is equal to 5, times n plus 1, which is 6, over 2, and remember we're multiplying this by 8. And from here on forward is just simple algebra. These 6's cancel out, which give you with 55, plus 5 times 30 is 5 times 6 is 30, times 8 is 240, divided by 2 is 120, minus 10. 55 plus 120 gives you 175, 175 minus 10, which gives you 165. And that is the approximation using sigma or summation notation of the area under the curve of that equation. So that's basically what the first two sections of chapter 4 are. So, like mentioned before, we also have definite integration, and that's where chapter 4, section 3 comes into play. Let's use the same examples before, and let's do 0 and 1 just to keep it simple. So the same process applies. We have x to the n plus 1 over n plus 1, which gives you x cubed over 3. We do not put it c, instead we are going to evaluate at 1 and 0. The formula for this states that once you plug in f of b, you're going to subtract that by f of a, which is 0, and that is going to give you your answer. In this case, we're just going to substitute 1 into the equation, which is just 1 over 3 minus 0. So the answer to this would be 1 over 3. And that is the answer to definite integration. That has been chapter 4, section 3. There are other times where the derivative of your inside function would be a number on the outside of the integration. So basically, this is the integration for the chain rule in derivatives. So like the chain rule in derivatives, we have a function inside of a function. Here we can clearly see that there is a function inside a function, the function being x squared and the inside function being x plus 1. Now let me ask you, what is the derivative of x plus 1? To make things simpler, let's just set x plus 1 equal to u. And we find the derivative of u, we simply get 1 dx. This dx is here, and this 1 is technically right here, which means I can rewrite this to be the integration of u squared du. And of course, we can do this as u cubed over 3. And before we do anything else, we have to put the u, and we know u is equal to x plus 1, so we have x plus 1 cubed over 3 plus c. Again, we're putting this plus c because there are no bounds on our integration. So that is integration using u substitution. It's a very common process, and that basically summarizes all of chapter 4. Moving on to chapter 5, it's a swift chapter, and it only talks about finding the derivative of natural log and the exponential. So we have d dx of the natural log of x, and we have d dx, which is just a derivative of e to the x. The formula for this one right here is u prime over u being the x. So if we were to solve for this, what is the derivative of x? It's just 1 over u, which is just x. So the derivative of natural log of x is 1x. Now, if we find the derivative of the exponential, we get u prime over e to the u. So, u prime being x again, the derivative of x is 1. So we just leave 1 and then e of x. So we just left with e of x. So now let's use some examples to see if we got this down. Let's do the derivative of the natural log of x to the 4th. So again, u prime over u. So the derivative of this is 4x cubed. And we have a natural log, so 4 natural log of x cubed over just u, which is x. And that has been that. Now let's find the derivative of, now let's do it fancy. Like the previous derivative rules that we've learned, we also have to do the product rule with exponential rule. So we know that it's f prime g times f g prime. So we find the derivative of x being x cubed, we get 3x squared times ex plus f of g prime, which is just e to the x, because derivative of x is 1, and then we just multiply by that, which is just e of x. There is no simplification needed unless specified, making that your final answer. That's basically what chapter 5 is about. So now moving on to chapter 7. As we well know, integration talks about finding the area between curves. But what happens when there are more than one curves? To further explain this, let's just make an f of x and a g of x. And just to keep things simple, let's use parabolas. So we know that a parabola is x squared, and let's make one of them negative because obviously they have to intersect. So let's do 2x plus 3. Let's keep this 3 and do minus 4x. So the first thing you would do is graph this, of course. If you have a graphing calculator, feel free to use it. So it's gonna look something like that. Sorry for the crude drawing. And from here we can already determine our x-intercepts. So we can determine that x is equal to 0 and 3. We obviously know that this is a and that this is b. So we can set those as our bounds for our integration. 0 and 3. So we are trying to find the area of this. So we're going to find the area of this and subtract it by the area of the one here. The rule says that we have to get the one on the top, in this case it being the negative parabola, so negative x squared plus 2x plus 3, minus the one on the bottom, which in this case is the positive parabola, which is x squared minus 4x plus 3. And of course dx. So now from here, it's basic integration and basic algebra. So to simplify this a little, I'm going to get rid of these parentheses and distribute the negative 1, making this a negative x squared, a positive 4x, because negative times negative gives you a positive, and then minus 3. These negative 3 and a positive 3 automatically cancel out, and these negative x squareds would automatically turn to negative x squared plus 6x. And remember, we only rewrote, we did not integrate it. So now we have to integrate. That becomes a 3, which means we have negative 2/3 x cubed plus 3x squared. We're going to evaluate that at 0 and 3. So now we have 2 over 3, and that is negative, times 3 cubed plus 3x, and the x being 3, sorry, so 3 times 3 squared. We can rewrite that as 3 cubed plus 3 cubed times 2 over 3, and that's negative. So 3 cubed we know is 27. This is automatically going to be negative. 3 times 3 is 27, times 2 is 54, divided by 3 is 18. So negative 18 plus 27, or just 27 minus 18, which gives you 9. So the